The safety, honor, and welfare of your country comes first. Run! Your own ease and comfort will come last.
You are charged with Indian Army Act Section 41, waging war against the king.
Fire! रात दिन अपने सीने विच वजदी आजादी दे राग नूं बंद कर ला। सब तो पहला मैं हिंदुस्तानी हाँ।
Welcome to this episode of Eureka. Imagine you have a 100-page book and somebody tells you that 98 pages of it, not necessarily one by one, but put together, 98 pages of it is just junk, and in between about 2 pages of matter is actually the story. That's what people thought once upon a time DNA is. They thought 98% of DNA is junk DNA. Today, our understanding has changed and is changing. One of the person who made an important contribution to make this change is the guest we have today for this episode of Eureka, and that is Subhash Chandra Lakhotia, Distinguished Professor of Banaras Hindu University, Department of Zoology. Before we start our conversation with him, let's take a quick look at his brief profile.
Professor Subhash Chandra Lakhotia is a renowned Indian cytogenicist who was born in Churu city of Rajasthan state in 1945. Professor Lakhotia is presently a distinguished professor at Zoology Department of Banaras Hindu University and has nearly 5 decades of research and teaching experience in cytogenics and gene expression. He obtained his PhD under late Professor A.S. Mukherjee in the Department of Zoology of Calcutta University in 1970. After that, did his postdoctoral studies at Delhi University and thereafter started his career as a lecturer at Burdwan University in 1971. Professor Lakhotia, known for his pioneering researches in Drosophila with regard to its chromosome organization and replication, has worked on to understand the regulation of gene expression, roles of non-coding RNAs, cell stress response, etc. using the fruit fly model. He is currently also engaged in Ayurvedic biology research using fly models for neurodegenerative disorders. Professor Lakhotia published many articles in renowned journals and also received many national and international recognitions. Noted among them are INSA Young Scientist Medal, Shanti Swarup Bhatnagar Prize for his contributions to biological sciences.
Thank you, sir. It's a wonderful opportunity to meet with you who had more than 4 decades, I should say close to about 5 decades of teaching experience and research experience in science. I mean, you are a doyen of Indian science, and I'm very glad that I have been able to come here and meet you. Let me start with this question. About 55 years ago, you would have made your choice to go towards science and research. That's not a time when in India we were thinking that science is bright or science is, would have possibilities. People would be looking for, doing something to get a job, maybe a school teacher or something like that. Largely, most of us coming from a middle class family, not necessarily from a rich family. How did you happen to come into science?
Well, my coming to science was my childhood dream. But this was unusual. Coming from a typical Marwadi business community, I had my dreams of doing science, more in human health. And so in my school, I took biology, hoping to become a medical doctor and do human health related research. But then my school result was awfully bad.
Oh.
And in 1961, when I finished, my father couldn't afford the fee for a medical admission.
Oh, okay.
You know, my marks would carry me, and money my father didn't have. So then I decided to study BSc. And that time itself I took to my decision that I'll be teaching and I'll be doing research. And so that's how it has gone on. It's from 61 on that I was clear what I want to do.
Very interesting, but then I heard a story that after you finished your PhD, there was a time when you had no job and somebody offered you a job and you said that get lost.
Well, not get lost, but then the job offer was, I was...
What is that story? Can I hear the
Well,
whole story?
it's... you see, this was... I was doing a postdoc in Delhi University. I didn't go abroad after my PhD because I wanted to stay back in country and do things here. So I was doing postdoc in Delhi, and there was a conference going on there. There were some senior scientists from BRC, from the biomedical group. And they talked to me and apparently liked me and thought that I could set up a Drosophila lab in BRC. And so they offered that, why don't you come and join? And I was, I should say cut, I wouldn't say get lost, but I was very clear that I'm not interested in joining an institute. I wanted to do teaching. And that's what I told them, that I will join a university or a teaching job. Firstly, because then I can do what I want to do. In terms of research, I don't have to direct it that do this or do that. I can do what interests me. And secondly, by teaching is something that I really enjoyed. And so I'm glad I took that decision. And there have been opportunities once later on also, once in a while, then there's possibility that I could have moved from university to an institute, but
You were your
I
love
was
for
clear,
university
yes.
and students is much more than those kinds
that's
of...
right. Even position of vice chancellorship, I denied without even thinking twice. The concerned officer in ministry was shocked that, why don't you want to think even overnight? I said, I don't have to. I'm not cut for that kind of job, and I enjoy teaching, and I will enjoy teaching.
Let me move to another area. It's a proverbial story that of Archimedes shouting Eureka when he found something very, very interesting and then running on streets naked. But of course, modern times you don't actually run on streets naked, but sure, at least in your mind, you would tell Eureka. So, was there any Eureka moment in your whole 40, 50
not
years of...
exactly that kind of Eureka moment, but yes, more or less similar that yes, you found something very interesting. And one was when I joined PhD, I was working with Drosophila, the little fruit fly, which you see around large number of them. And I was interested in I took up a problem where I had to study the phenomenon of what is known as doses compensation. That is, males have only one X chromosome and females have two. And still the genes which are not involved in sex determinant but are involved in body function, they express an equal level. So this phenomenon was called doses compensation. And in Drosophila it was just shown by my supervisor that it works by making the male X produce as much transcript, as much RNA as two X chromosomes in female do. So I took up that. This theory was just given a few years back, and I was one of the first to start working on this. And then there were several questions around it. There were two great geneticists, one Muller and the other Goldschmidt, who had very different theories, and I read their work. I wasn't happy with either of them. So then I had a dream that this is the kind of experiment I should do. And next day morning, I started doing that experiment. And in 3 months, I had excellent results. That was one of the Eureka moment, I can say. And the paper was published very quickly, without a revision. And I consider that was one of the best things that I did.
Interesting. We need to take a very small break. We'll take a very small break. Don't go away. This was one Eureka moment, and there are more to come. That's just in his PhD, when he was not even, where you can say that he was not even completely had finished his studies. It was in the transition stage. Keep watching Eureka. We are going to have really very wonderful stories. We'll take a very short break. Welcome back to Eureka, and we are having a very interesting and engaging conversation with Professor Lakhotia, who is a distinguished professor of Banaras Hindu University, Department of Zoology. Before the break, we were talking about your work during your PhD, and we were talking about what perhaps we can call as Eureka movement, and you mentioned that as one important one where you really found very interesting stuff, and you were about to tell us about two more, and we had to take a short break. Can you?
Well, one more happened during PhD again. While looking at this X-chromosome activity, I saw an observation which I can call serendipity. I did something, but something else was happening in the cells which caught my attention, and I decided that will be my later on work. And this observation I made in 1969, and it keeps me engaged till today.
What is that actually?
That has become my major, what you mentioned in the beginning about non-coding or the junk DNA. And this gene we found in 1982 was a gene of that category, which didn't make any protein. And just in 1981 has come the concept of junk DNA and selfish DNA. And in 1982 we discovered that, okay, this gene is there in different species of the Drosophila, but it doesn't make protein. And most would have thrown it out, as my competitors in MIT and Europe, who started working on this following our leads, they had to give within few years because they wouldn't get funded.
Okay.
Because this is junk and selfish. I didn't believe in that. I never believed in something in nature being that kind of a...
So let me try to understand this bit. Suppose I'm building a building. Okay, I have used a lot of bricks. And there will be, of course, some bricks which I don't use, which will be lying there. Maybe there will be some empty paint dabba which will be lying on that side. Some wood, like... So people once thought that the DNA, which actually makes protein by which our body is made, there are lots of this kind of junks. That's what was called as junk DNA, right?
It was not exactly this. This was that this DNA has, you see, the selfish and junk DNA have two different connotations. Selfish means that this DNA has somehow come in our system and we can't get rid of it. Because it's selfish, so it perpetuates itself. Junk, on the other hand, would say, as the word junk means, it had some use in yesterday time, but now it is useless. Okay. But we can't get rid of it. To me, both concepts were wrong.
Okay.
Because, well, a small part may be there which may not have an immediate function, but to imagine that a large part will be just sitting there and we can't get rid of it, I never believed it. Yes, it was a difficult time following when the whole of the world talks about
something,
this thing, and then you are, but you know something that I may share with everyone. It was in India that I got Bhatnagar Prize for work on this junk DNA. In the heydays of junk DNA, when no one in the world was talking about this, but I am glad that we could do basic research, we could continue with our ideas, and I got that recognition. And that was, of course, an encouragement to continue. And now we know that this RNA is very important. Yes, I can feel very happy. Whole of the world is now jumping off with this non-coding DNA.
Okay.
Now we are beginning to understand that, and the simple thing is, the molecular biology reductionist approach got lost in somewhere. We thought, okay, one molecule does something, but biology is not
that simple.
That simple. In biology, as we commonly say, sum of parts is not equal to whole. That there's organization, and that organism needs regulation, and this regulation needs many more complex web system, and this non-coding RNA does precisely that.
That kind of
yes.
Okay. The third area which you would like to...
Third area, well, there have been many other areas, but third is something more recent, where I got involved in what has been named as Ayurvedic biology.
Okay.
Which was started by Prof. Veliathan's and Dr. Chidambaram's effort, that we need to understand the basic biology underlying Ayurveda, the traditional Indian healthcare system, which, I mean, we know that it's there for thousands of years, but we don't understand in modern scientific terms the basis, its effectiveness, and whether it works or not. We are going by faith and go. So he started, and then I somehow got in, and I suggested that I can use Drosophila also as a model. Obviously, this was a big surprise and a big shock to traditional Ayurvedic people, because where do in Drosophila we find Vata, Pitta, Kapha, and so on and so forth.
Okay.
But I suggested that Drosophila is a very good model for human diseases, and we should go ahead. And Professor Veliathan and Dr. Chidambaram were convinced, and they let me be party to this. And today I'm very happy that we started this, because we could now establish a very good model where you can look at biological action, we can understand how do they work, whether they work or not. This is, both things are there.
Both things are there.
We read, okay, this formulation does for this, and it's taken as a faith. But we do not know whether it works, and if it works, what's the mechanism, which we can now use with Drosophila. And that's where I think we have, one of the remarkable things that we have been able to do is, find out is, for example, neurodegenerative disorders have become very common.
Okay.
Alzheimer's and similar things. They are becoming more and more popular as we live longer.
Yeah.
Age-related diseases are becoming common, and we have no cure for this. But it looks like in Ayurveda, the two rasayan that we have tested, Amla ki rasayan, derived from Amla, one of the very common things, and the other is a mercury-based bhasm, Ras Sindoor. Mercury, which is considered the most toxic of all, but this is one of the most potent Ayurvedic formulation. And each one of them can suppress these diseases substantially. And so that has been something very satisfying. And now, more recently, I've been collaborating with some other scientists, for example, with Dr. Patel in CCMB. And what we saw in Drosophila happens in mouse as well.
Okay.
And so that gives us
Some
tremendous
confidence to
hope
work further.
that yes, it should work in humans. Now it's up to the Ayurvedic community to start
Research and
research and work on it. One good part in Ayurveda is you don't need a license or human trials and so on. So, and these are basically harmless. You see, one more good part that we could show was, you see, many Ayurvedic formulations were banned to be exported to US and Europe.
Yeah.
Because they thought it contains heavy metals. But no, what we could show was, once it is processed in a proper way, in this form, mercury is completely harmless.
It doesn't do the...
Absolutely no damage. Unless you consume it in large quantities. But once you take the appropriate doses, it's very good. So that has been something very satisfying, and now I'm continuing in that as well.
Very, very interesting. I mean, you had a very interesting career with the multiple, research problems to tackle. And quite sure, I mean, we just talked about 3, I mean, you would have also done quite a lot more. Let me ask a very, very short and simple question. Like, in this particular field, where you are looking at the DNA and how the, genes are coded, and what are the major questions which people are engaging today?
See, there are multiple questions. One, of course, is how do genes express, how do they get regulated? Once you talk a multicellular organism, we begin to ask how the cells communicate, how they coordinate each other, and more important is how does a zygote develop into an individual? Where from the information comes, who shapes it, how it is shaped. So I have broad interest in developmental biology also. I may not have done much research, but I've been, in some of my own studies, I've been trying to look at from that point of view. Plus, a part of teaching, I find it very exciting.
Very exciting.
To explain to the students and then to share them with them the excitement that it goes at, that how does a zygote know? You don't need a sculpture, somebody to come from outside to give the shape, and it comes from within. So that biological organization is something that is very exciting.
The conversation is going very interesting. We'll take a very short break. After the break, I'm going to ask the question. We know something. We know that we don't know a lot of things. So where are we? This is a question that I'm going to ask him after the break. Keep watching Eureka. Welcome back to Eureka, and we are having a very wonderful conversation with Professor Lakhotia, Distinguished Professor of Banaras Hindu University, Department of Zoology. You are explaining number of fascinating, features which we are now seeing when we start exploring into our cells, how the DNA works and all that. It's about 1950s we came to know that something called DNA exists, perhaps that codes how the proteins are made, and perhaps that is the kind of basic book of life, like some people say, right? So from that time to today, roughly about 60 years have passed. We have gathered quite a lot of knowledge, but then we also seem to know that a lot of things we don't know, right? So if you compare this, where do you think we are?
Well, you see, it's something interesting to think about. When I look at, and because I have been reading literature prior to 1950s, some of the great thinkers and scientists have spoken some very fascinating kinds of ideas. They're not constrained by today's reviewers and today's publication. So some of them had great ideas. Now we can see them, we can understand them, we can know the mechanism underlying it. But more important than that is, I'm not going to touch the application part of it.
Okay.
Application part is something that I would always say, to be able to design better machines, we need to understand life.
Yeah.
There's nothing like a machine that life is.
Yeah.
And to be able to understand that, today now that we know that where the genetic information comes from, we know how the cell organizes it, we know how they communicate, we are beginning to understand a little bit about brain. Putting all things together, the important point is we need to understand biology as a network system rather than individual molecules and individual targets. It has to be looked at from a holistic point of view, interacting point of view, and that's when that is happening, we really get excited.
Okay.
And then, so like my typical phrase is, when you said that we still don't know a lot, I tell my students that when you know something, what you know is what you do not know.
Okay. That's a very interesting
Yes.
thing to say in science. I know.
That's right. That's every time we do research, we find some question, then yes, you see many more questions.
Yeah, many more dark areas which
you still do not
you
know. But
that,
prior to that, you didn't even know that can happen.
that can. Yeah, it's an interesting point. Let me shift to another area. You have been in this university for more than about 40 years now. You have been in the university system, and you love to be in the university system. When opportunities came, you did not even want to go there. But what is the state of university system in India? What do you think is our major malaise?
Well, even to talk about it makes one sad. The state of university system is really pathetic, our own doing. If I put it in biological terms, in biology we know two kinds by which a cell dies.
Yeah.
One is other skillet, and second is what we call programmed cell death, apoptosis. That cell decides to kill itself under certain conditions. And our education system had done that, both.
Both.
The way we have managed our universities, the way we have allowed them to decay, they are, I would say, undergoing programmed cell death. Extraneous conditions have not been conducive for a healthy growth of the university system, and therefore it has also gone bad. You see, what has happened is, once you get into a vicious circle of mediocrity, getting a better situation becomes very difficult. And the result is, with increasing population, youth have tremendous dreams and aspirations. And we give them more aspiration, which is what we should do. But then, do we give them the wherewithal by which they can fulfill their aspirations? So we don't teach them properly, we don't mentor them, we just give some information, some data, some techniques. At least in biology teaching, most places all that we are teaching is techniques, without giving them the background information, and consequently, they finish up with our masters or PhDs fit for nothing.
Now, this is the situation, sorry state that we are in. What do you think we should be doing as a nation?
Well, as a nation, we need to do some very drastic steps. Opening new institutes is good, but that can't solve the problem of billions of people that we have around. And the incremental things that are going into build up universities and colleges, which today we say are irretrievable, but I don't think they are irretrievable. If we have the will, we have the design, we have the wherewithal to do it, we need good amount of funding. But more than funding is, we need to have people who are interested in retrieval. Once we get, my experience tells me, any department, any university, if it has 10% good faculty, students are blessed. Even one good teacher can catalyze, convert, as happened with me. As I said, my school result was very poor. Fortunately for me, for 2 months I got a teacher who came and went away, catalyzed me, I became a university topper. And I haven't seen back. But if that teacher was not there in my life, I don't know.
Yeah.
So that's where I tell people that, look, maybe we don't teach regularly, but if some of the scientists who are involved in many things, they can spare some time, mentor students, help at least some of them to come into realize their potential, we can make a lot
We
of
can make a lot of. Our time is running out, but this question I should certainly ask and then ask your response for it, which is, what's your take-home message to our young viewers?
Well, young viewers is, don't get frustrated. Believe in yourself. Do things honestly and do things with a commitment. Commitment to yourself, commitment to family, society and country and to humanity in general. In India particularly, when I look at the young kids and I look back myself 50 years ago, I am convinced that they are much, much smarter than us. We were not that smart, not that confident, but unfortunately they are losing directions. There's nobody to mentor them, and therefore many of the mid and senior level people who are academics need to take this responsibility. Maybe their jobs are research, but they should find some time to mentor, to help fulfill the dreams of these young generation.
Very important point, I think, in this particular situation when India is slowly and steadily becoming Youngistan. The statistics show that in another 1 decade or 2 decades, we are going to have the world's most youngest people in this country. If those young people have to realize their potential, as our guest today is pointing out, we need to spend our time in mentoring, and the young people should also not get frustrated, work with commitment. This is a message that we are getting out of this conversation. Thank you, sir. Thank you for being with us. It's a wonderful conversation. Keep watching Eureka. We'll come back with another interesting conversation next week.